Mary had a little lamb. But the zombies got it. And they got Mary too. No, no. All right, we're going to show you how to do this exact same problem of our 3 by 3 by 2 ANOVA, or factorial ANOVA, with no repeated measures, using this data. This is the raw data. Using the statistical software program, SPSS. It will save you a ton of time. So give me a second. Let me pull it up. Okay, from the front page of the SPSS program, this is version 19 for anybody that's still out there. What we have to do is we have to go to the variable view, right in the bottom left-hand corner. A lot of the basic stuff I'm not going to go over here. There are lots of other videos out there that we've already made that you can see the basics. But you got to go to variable view. We got to label our variables. I'm going to keep it simple. I'm going to call the first one IV underscore A. Remember, in the name column for SPSS, you can't have blanks, you can't have apostrophes, you can't have a lot of things. So just be careful. Name them basic. So IVA, type, we're going to leave it numeric. Width, that just tells you how many characters you can use. Decimals, because they're all categorical, I'm going to do it down to 0. Labels, this is our weapons variable. Values, this is where you label your levels. Right, so 1 was loud weapons, add. 2 were quiet weapons, oops, quiet. And 3 were the handhelds, right, add. So now those are our 3 levels to our IVA, which is weapons. Click OK. Okay, missing, don't worry about that. Columns, align, measure. We gotta name this. This is a nominal variable, right? Categorical variable. So our second variable, I'm just gonna name it IV underscore B, and everything's gonna be the same. I'm gonna change the decimals down to 0. Values. Oop, yeah, okay, let's name the values now. We'll go back. So 1 was smashy and grabby, my personal favorite. 2 was stealth, sneaky. And 3 was hide and seek. So those are our 3 tactics. Let's go back to the label one, and we'll just call it tactics. And again, we need to label it at what type of variable it is, right? A scale is a continuous, is a regular number. And our IVs with the ANOVAs, remember, they all have to be categorical. So there's our categorical variable. And then our last one was IV underscore C. And no decimals. The label was, we'll just call it alone or not. And we're going to spell it right, A-L-O-N-E, or not. And values will make 0. We'll call that not alone. We'll add, and then 1 will be yes, they were alone. Okay. Boom. And that's our categorical variable as well. Boom. And our last one is the DV, right? That was the number of missions. And that is numeric. Decimals, because they're all whole numbers, we're just going to leave it at no decimals. Label will just say the number of missions that they returned from. Hold on. Number missions. Values, this is not a categorical variable. We're going to go all the way over to measure, and we're going to call that a scale number. Okay? So now, so far, so good. We got our 3 IVs and our 1 DV. So here comes the hard part. We got to put everybody in a category. But let's look at the data real quick. So here's your group A, right? A1, A2, A3. Here's your group B. See, they're all split up. B1, B2, B3, all under A1, et cetera, et cetera. And then here's your C's. So we got to kind of figure out how we're going to enter this data. So let's just pick this first cell, right? They're all A1s. But then the B's go 1, 2, 3, and they're all under C1s. So watch how I do this. You know, entering this data correctly under each level is almost the hardest thing about using SPSS. After you use it for a while, it becomes a lot easier. But now let's go back and look at the raw data. Under the A1, B1 column at C1, you'll notice it's A1 at B1 at C1. So we're going to go down. 7, 4, 5, 6, right? So that's everything in that first column. Second column, A1, right? They're all, the next 4 of them are going to be 1s. 1, 2, 3, 4, 1s. And the B's are all going to be 2s. So 4 B's. And they're all under the 1. So the next column is 2, 4, 3, 3. Boom. This one, they switched over to the B column. Okay, so it's going to be 4, 3, 0. Ooh, 0. Bad news. 3. That means this person never returned. Ooh, spooky. Okay, so that's the first column. It's the first box. Kabam. So now let's jump over to A2. Right? We're under A2. So there's going to be 1, 2, 3. There's going to be 12 A2s, and then the B's are going to be the same. They're going to be 4 1s, 4 2s, 4 3s, and they're still under C1. So let's go ahead and put those in there. 10, 7, 6, 8, right? Jumping over 1, so A2 at B2, still in C1, is 4, 6, 3, 5, and then it jumps over to B3. Okay, so A2, B3 at C1 is 7, 4, 5, 5. So I'm going to go ahead and fill in the rest of the data. Please hold. All right, here's all the data. It's always a good idea to just check something at random. So I'm going to pick these 4. And, okay, these 4. So that means A2 at B1 at C2. Remember, C2 means that they were not alone. We coded it a little bit differently in SPSS, where 0 means that they were not alone. Okay, so we're going to go to A2B1 C0. Looking at the chart over here, come on brain, A2B1 C0. So C2 on the bottom, A2, that's the middle column, and B1 is the first one. So it should be 6, 5, 5, 6. So we got it right. So now we have to check for the assumptions of an ANOVA. Remember, we're going to check normality. So we're going to go to descriptive statistics, explore, and let me take these out of here. It doesn't make sense to look for normality in a categorical variable. Okay, nominal variables, you don't have to worry about that. Okay, basically we're just going to look for the dependent IV, because that's the only scale number. That's the one that can be seriously skewed. So we're going to check for outliers. We're going to look at the histogram. That'll tell us how normal it is. And we don't have any missing data, so because we made it up. So we're going to go ahead and click OK. Now this little thing over here tells you, right, if you just want to click at a specific graph or something, you could just click on it. So, but let's go down and see what we got here. So it means for our DVs, we got 72 participants, subjects, nobody's missing, okay? So there's the mean number of return trips is about 5.5. Standard deviation is about 3. Okay, that's pretty good. So this is one way to look at it. We're looking at our skew score. It's a little bit skewed, okay? But if this number is roughly under 2, you're okay. Same with kurtosis. Kurtosis means you're missing too many subjects in the middle. So, but our data, it's not perfect, but it looks like it's going to be okay. And these are extreme values, right? This is the case number. These are the numbers. Da, 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 da. That doesn't mean they're outliers per se. But here's how you see if it's normal. And it's relatively normal. Again, it's not perfect, but it's good enough. ANOVAs are very robust. That means it takes a lot to really screw them up here. And here's our box plot, which is basically saying the same thing as a histogram. This is a little bit skewed to the top. Okay, so it's positively skewed a little bit, but that's not going to hurt anybody. So far, so good. Let's go to Analyze. General linear model. Univariate, that means 1 dV. Our dV is the number of missions, and the rest of these are our fixed factors, right? And then we just click all these buttons and see what they have to say. Okay, it's going to do a full factorial. That's fine with me. Contrasts are the same as planned comparisons. Plots, don't need plots. Post hoc test. I'm a big believer in the Tukey test. It's fast and easy. It'll tell you exactly between which levels of which groups have the significant difference. And any more options? Sure. Effect size, power, homogeneity. Okay, let's do them all. Click continue. Click OK. Okay, the first warning is the Tukey test can't be worked on any variable that has less than 3 levels. So variable C only had 2 levels, so we're not going to get a Tukey test on that. That's what this means. So, but here's our between subjects. It tells you how many are in each group. Okay. And here's the descriptive statistics. All the means and the standard deviations, right? How many were in each group. Which we have on the one we calculated by hand. We did that as well. Okay, first test, Levine's test. This tells you that your homogeneity of variance assumption has not been violated because the significance number, which is under this annoying little double click sign, this number, 0.133, is not less than 0.05. If it was, then you would have broken the assumption of homogeneity of variance, and this test is probably not the right test to use. But here's your money right here. Here's your ANOVA table. Okay, so the overall model, you got a giant F. Bam. Significant. So it means there's a significant difference between the levels of all these groups somewhere. And your eta squared, that is your effect size, is about 86%. So in other words, about 86% of the variance that you can explain here in the DV can be explained by this model, which is good. And the power is fine, it's strong. So now, don't look at the intercept, but let's look at the IVA. So weapons, right? These numbers are the same F scores that we calculated by hand. So a giant F, small significance. So that means that, yes, there's a significant difference which type of weapons these guys used, right? And then 77% of the variance can be explained by that. Dropping down to B, the tactics. Again, 59 for an F score, that's huge. So we got a significant difference between the tactics. C, whether they're alone or not. Correct, yes. We got the exact same results. Significant difference. So there's a main effect A, main effect B, main effect C. That means there's a significant difference between the weapons, the tactics, and whether they go alone or not. And here's our interaction scores. So no, there is no interaction between the weapon type and the tactic, but there is between the weapon type and whether they go alone or not, and no interaction between the tactic and whether they go alone or not, and no overall interaction. Wow, that's exactly what we got by hand. We must be good. So there's your R squared again. That's like 86% of the variance. In other words, you can explain, you could predict pretty well, accurately, by which category they're going to be in for the weapons, the tactics, or whether they're alone or not when it comes to how many returns they're going to make. So that's about it. We don't really look at that. But let's look at the post hoc tests. That's going to tell us where the biggest differences were. So between the loud and quiet weapons, there was a significant difference. Between the loud and the handheld weapons, there was a significant difference. So when it comes to weapons, yes, there's a significant difference which weapon to take. Okay? And I think that's about it. We don't look at homogeneous subsets. But here's our tactics. And same thing, there's a significant difference between smash and grab and stealth, smash and grab and hide and seek, but not between stealth and hide and seek. That's what this says, right? Hide and seek and stealth was not significant difference. So that's it. I hope you enjoyed the series. And again, don't let the zombies get you. MGZ.